example 6 is going to expose another limit law for us. So on the first one, the red one, we've got the limit as x approaches 1 of the square root of x. We have the square root function. And if I look at 1, we can see that it seems to be very well behaved right there, and it approaches 1. The value of that limit is equal to 1, which is basically the square root of 1. It's as if we are allowed to directly substitute it into the square root function. On the right, in purple, we have the cube root function, the limit as x approaches -1 of the cube root of x. Let's look at the graph around -1, and it looks like the y values on both sides of that are approaching -1, and that is, again, the same exact thing that I would have gotten by just directly substituting -1 into that cube root function. What that means, of course, is that for radical functions, just like with polynomials and just like with rational functions, when you're taking the limit, you're allowed to directly substitute in your value. Let n be a positive integer, and the following limit is valid for all a if n is odd. In other words, if we have a cube root, a fifth root, or something like that, and is valid for a greater than 0 if n is even, because we don't want imaginary numbers. So if we have a square root, a fourth root, then the stuff that's inside has to be positive. So we have the limit as x approaches a of the nth root of x. That should just be equal to the nth root of a, direct substitution. All right? And then we have the same thing, but a function that we're taking the nth root of. So we have the limit as x approaches a of the nth root of f of x. That allows us to evaluate the limit as x approaches a of f of x, and then just take the nth root of that whole entire thing, and that's called the root law. All right, I don't think that we have enough laws yet. So think about what kind of functions have we left off of the list so far. And what we have are things like this. So it asks us to evaluate each of these limits, and we have sine x and we have tangent x, and we have graphs to go along with it. So on the left-hand side, we want to evaluate the limit as x approaches 0, and it looks like sine x is approaching 0 from both sides, so it's equal to 0. Fantastic. All right, so the limit as x approaches pi over 4 for tangent. So pi over 4 would be this little tick mark here, and I follow it up on the graph, and on the other side it looks like it's approaching 1. So again, we got direct substitution, which is perfectly okay. Now, what we are going to say, though, is that it's perfectly okay to do a direct substitution as long as what we are directly substituting in is part of the domain. Let's say, for example, if we look at this, the tangent graph, and I go try to evaluate the limit as x approaches pi over 2 of the tangent of x. Here I can't directly substitute it in there because pi over 2 is not part of the domain of tangent. You have this vertical asymptote right here. And as a matter of fact, you would have to break this up as left and right side limits because one side goes to positive infinity and one side goes to negative infinity. So you can see limits of trig functions. Let a be a real number in the domain of the given trigonometric function. So it has to be part of the domain. And so each one of these is saying that, hey, when I have sine, I can just directly substitute it in. Cosine, tangent, cotangent, secant, and cosecant. And again, once again, we want to make sure that whatever it is that we're directly substituting in is part of the domain of that function. If it is, it's direct substitution, and you're done. It's the same thing as the value of the function. And the reason why, as we will see in another lesson, is because the function is continuous at that particular point, and the limit and the function value are identical. And we have to figure out what to do when it's not identical, when it's not in the domain. Chances are you have some sort of asymptote or a hole that you have to fill. All right, one last set of examples for this first part here. On example 8, evaluate the following limits. And each one of these, we have ourselves some trig functions. So I want you to go ahead and probably pause the video so you can see these limits up there on your screen, and you give them a try on your own, and then check the answers in the follow-up video.